Now, today we will start the lab, but before I start the lab, I'm going to again walk you through the exercise, and then we are going to talk about, I'm going to explain the exercise, the mat mull again. You can understand that we are going very, very slow in the beginning because I want you to grasp these ideas of matrix multiplication, GPU, CPU, all of this, because now it's imperative that your set of people understand this, because you are going to live in this world, and we don't want you to become jobless wonders. So the work is going to happen here. Now, as I walk you through the program, I will try and elaborate as much as I can. You're free to obviously ask questions. You're also, I'm hoping, have a chat GPT session ready in case there are some terms which I talk about and you are not able to understand, or you want to go deeper and try to think about those terms. That also you should use. And hopefully you will have a good session with the tantric, and I'll explain a little bit about the tantric. I'll explain a little bit about how we are building the platform for you. It's a little different from the Tufan setup that you have, and you will soon get to understand how it happens. So the tantric link, we are going to give it from here.
Yeah.
We give it separately. No, it doesn't come from here. Okay. So anyway, before we start the tantric session, I will give a overview of what we are going to do. I'm just waiting for people to come in, and we are just beginning to start. Uh, okay. Now, okay. First, let me show you what it's again a kind of revision of what we talked about last week, and let me start by doing, as usual, a bit of revision of what we have been doing so far, and so that you have a understanding of where we are and how we are going to do. So where are we? So I'll just give a overview of where are we, so that you are with us. So we started with a neural network. If you remember, we had the X initially, and we had the neural network with certain number of neurons, and we had all this. We said this could be multiple layers, if you remember, and then each of our X could be one row of data. So each X, you remember, is connected to one neuron. Each of them is connected to every neuron, and this is to show rows of data. So this is my X. These weights are my W, and I am forgetting the bias for a moment. So our whole operation of a neural network requires me to multiply rows of data with W, these weights, and that's how I get this output. And then it goes on past to the next layers. So this is, let's say, W1, W1x. Then this gets multiplied by the weights over here, which are W2, which may be a different number of neurons and all of that. And finally, you get an output here. So we have not yet reached the output. In fact, we are just working on this arithmetic and this logic, so much so in over the last 2-3 weeks. So we said that these weights are going to be multiplied with X. X is visualized as a matrix. You know why X is a matrix? X is a matrix because if you take the analogy, and I have already explained it in earlier session. So we said if X is a patient, X is a data about patients, then the way X looks like is like this, where we have multiple patients, and for each patient we have his diastolic blood pressure, his systolic blood pressure, his gender, his weight, and maybe some other, his cholesterol levels, and all of that. And obviously, we also have a why, whether he needs medication or not. So, why means whether there is medication required if these are the parameters or not. This is cholesterol, weight, gender. There would be age also. There could be a many number of parameters. So this is all your X. This complete thing is your X. So each X row consists of all these attributes, and all of that is multiplied by a batch. So normally, when we train neural networks, we'll be taking millions of samples, millions of patients, and we normally take a batch of patients at one time and forward it through the network. So if you are going to take a batch, maybe batches of 100 people, then the matrix that we are going to deal with here is 100 into each is at the level of the matrix is 1 2 3 4 5. This is not counted, so 100 into 5 if you have to take this matrix into consideration. And if you have so we are dealing with 100 into 5 matrix as X. 100 is the number of samples in one batch, 5 is the number of attributes. And if we have weights, if there are, let's say, 4 neurons here, which is pretty less. In fact, there are hundreds of neurons also here. But if there are 4 neurons here, the total number of weights which will be there here are 20, because you will have 20 weights, so you'll have a 5 into 4 matrix, the total number of weights, because each of these parameters, each of these attributes will have to have its own weight. And because there are going to be 4 neurons here, each neuron has its own set of weights for each of the parameter, each of the attribute. So that is how I get 5 into 4. So in that case, W1X multiplication will look like 100 into 5 into 5 into 4. This will be the matrix multiplication. And if you multiply these two matrices, you'll get a 100 into 4 matrix, right? Because that's what you will get. So, and then that will go forward. But in real life, we said this will be much bigger, and because the number of attributes will be more, and the number of neurons will also be more. So typically in real life, we deal with multiplication of huge matrices, and therein lies the problem, isn't it? We talked about that. That that is where the problem starts. Okay. So we discussed this at length in the earlier sessions. Those of you who have not bothered to show up the last 3 sessions or so, you can. They are available now on KMIT Vista. They are, no? All 3.
KMIT Vista channel.
So I guess all 3 are available now on KMIT Vista, and I'm sure some of you would have had access to it. In case you have missed sessions, you can always go there and listen to that session all over again. It's the so I'll write it here. It's the KMIT Vista. That is the name of the YouTube channel. On that, I think we have created a playlist. I haven't seen it, but Vista, Vista. Okay. This is Vista. Yeah. So in case I haven't had occasion to see it, but I'm sure if our people are saying it's there, it's there. So it's there. So please look at it. Those of you who have not looked at it already, it will be a good place to revise also and attend before you come for this session, because these sessions are going to be very, very engaging, and over a few years, we are going to give you a complete insight of what is happening in AI and all that. So you attend these sessions, you will be an AI Dada. We guarantee that. If you don't attend these sessions, you will not be an AI Dada. You'll be one of the useless people. Okay, so that's as simple as that. And we talked about these matrices. We said these are huge multiplications. And in the last class, okay, now this is what we talked earlier. So let me take it a little forward. So we last class we talked about the Matmull problem. The Matmull problem is the matrix multiplication problem. Why you need to multiply matrices that you saw in the last just now. You have to do this Wx, and these matrices tend to be big, and you have to do this again and again for each layer of the neural network. And if you have to do it, then basically there are that many multiplications that you need to do. So if you have to do that many multiplications, you need a good machine which can do these multiplications, good algorithm which can do these multiplications. Now, we talked about matrix multiplication at length. We talked about the naive matrix multiplication. I'm going to show you this today and execute it and show you the amount of time it takes and all that kind of stuff, and demonstrate to you how it happens on a GPU. If you just get that, we have made progress. So the naive multiplication we talked about. So the naive multiplication proceeds like this. Let me just draw it for you, how the naive multiplication proceeds. So you have row and rows of data here, and here also you have, here I'm looking at data as a row. Here also I have rows and rows of data, but let me look at the data as columns, right? These are, there is rows, there is columns, there is obviously rows here. I'm just not showing you, because when you arrange data in columns, you obviously get rows also. But our focus is we are taking rows here and columns here when we are multiplying. Obviously, the number of columns in the second matrix, that is this size and this size should be same. The number of columns in the first matrix and number of rows in the second matrix should be same for matrix multiplication to happen. That's the basic law of matrix multiplication. So we just saw 100 into 5, that is my x, and my w is 5 into 4. That depends on the number of neurons. This 4 is the number of neurons, and therefore each neuron has 5 weights for 5 different inputs, and so that is what it is. So this was 5, this was 100, and this was 5, and this is 4. So that is how this matrix was interpreted. So these are huge matrices in real life. These are huge means very, very big matrices. So we must understand how to get to multiply this. The naive multiplication, which even I think 11th class student or a 12th class student knows how to do. I remember this is 11th class syllabus, matrix multiplication. I'm not sure, maybe 11th class. Yeah, I think it is 11th class syllabus, matrix multiplication. That even the most idiotic among you will know that in order to get the result here with naive multiplication, what you are taught in maths is this. In order to get this cell, what you have to do, you have to multiply this row with this row, this complete row with this complete row, and get that. To get this cell, you have to take this row and multiply it with this column. So first you take this row, multiply it with this column, you get this. You take this row and multiply it with this column, you get this, and so on and so forth. That's how you get the answers. Now, the point is, in naive multiplication, what happens is we have huge amount of idleness. Now, what do you mean by idleness? Doing nothing, basically. Because we have limited number of processing power, we have limited number of CPUs. What we do is, we first multiply this with this. We just do this operation. Then we take this same row and multiply it with this different column to get this. While we are doing that, so we keep doing this one after another sequentially. First we do this, then we do this, then we do this, then we do this. You remember, we'll get 100 into 4. So you'll get, if you take this, we'll get 100 into 4 answer. So each of this is going to take a certain unit of time. So if this multiplication takes, let's say, some L units of time, just this multiplication takes L units of time. And remember, here there are so many multiplications which are happening. How many multiplications are happening? If this is K, therefore this is K. There are K multiplications happening. This with this, this with this, remember there are k multiplications happening. So for each value, I have to get k multiplications to happen. Each value requires k multiplications. In this case, in our case, k is 5. So 5 multiplications have to happen for each value. And then how many such values I have to compute? I have to compute 100 into 4 values. If you see the total size of my result matrix with one batch consisting of 100 rows of data, the total number of multiplications I have to do is, total number of cells in the answer is 100 into 4, and each cell takes k units of time. So the total in this case k is 5. So the total time taken to do this multiplication is 100 into 4 into 5, which is about 2000 units of time, right? 2000 units of time is what is taken. I think I sold this idea a little while ago. I think everybody understood that the naive means stupid, or very very simplistic. What we used to do in the absence of GPUs, a non-AI world would do these kind of naive multiplications, and it would take about, in this kind of a thing, would take about 1000 units of time, because we were able to do only one multiplication or a limited number of multiplications at one time. If you had 3 CPUs, or let's say if you had 10 CPUs available, if you had 10 CPUs available, you would take how long to do this operation? I mean, if you were to write it elegantly and do it, you would still take maybe 200 units of time, right? Even if you had 10 CPUs, you would take 200 units of time. Now, most of our old hardware, okay, now I am going to go a little forward, which not little forward from last session, but I'm actually going to come to what the last session talked about, and tell you what the idea about GPU is. So a CPU, even if you had 10 CPU machine, even if you divided this work over 10 CPUs, you would still need to take 200 units of time, this for doing one multiplication. And remember, in an AI program, you have to do such millions of such multiplications. So it's going to be very, very slow, even with 10 CPU machine. Okay. Now, in the last session, I showed you the picture where we have, huge number of GPUs. We talked about an architecture with thousands and 10,000s of GPUs available. And if we have 10,000 GPUs or 10,000 core GPUs, sorry. So the idea is now, how can I make this even faster? So let's turn our attention to GPU and to appreciate this faster. Again, I am taking the task of multiplication. Again, I am going to talk about the same thing. There are rows here and there are columns here. Okay. Yeah. So I'm looking at this matrix row wise. I'm looking at this matrix column wise to help me understand how the multiplication happens, right? So if I'm looking at it that way, now if I'm computing, okay, now this is my result matrix. If I'm computing this in a CPU, what used to happen? Unless I compute this, I can't compute the next one or the next one. So each guy had to wait for the previous one to finish. Now, what is the GPU way of looking at these things is, they recognize that matrix multiplication is the big thing in AI computation. And if we have to make AI happen, then matrix multiplication has to happen fast. In fact, if you think back, there is nothing in AI, including transformers, including chat GPT or LLMs, there is nothing in AI which couldn't have happened maybe 20 years ago or even more. I'll say this again, and I hope some of you will understand. What I'm saying is a very profound statement. I'm saying there is nothing in AI which had to wait till 2024 or 2022, 23, whatever, for AI to burst into as such a big system. these algorithms which came and are today driving the world crazy could have come 25 years ago also. There is nothing so great. The only problem was the reason they didn't come earlier is because the computation speed was not available. The GPUs which we see, the enormous and humongous power and the brute strength which GPUs bring was not available. That was the only issue. It was not as if people discovered LLMs first time. People would have discovered that many years ago, at least couple of decades ago. And the reason they didn't discover that, I hope they are able to hear and all, no?
Yeah.
Yeah. So the reason they were not able to discover that was primarily because there was the absence of GPUs. Okay. That's what made things not happen. Okay. Hmm? Okay. Nagireddy here is getting a doubt. Are you able to hear us? Because we are seeing absolutely no questions and all things are in clear and slate. Huh? You're getting there? Okay. Now you're getting.
WhatsApp.
No, WhatsApp is showing?
In WhatsApp, students are asking questions.
Ah.
But I don't know.
Oh, okay. So can we put questions in the chat, not in the WhatsApp? Because for some reason we are not able to see them here.
Please respond if you have. Are you able to hear it first?
Okay. We are able to hear. Okay, fine, fine. That is all I wanted. Yeah. Arana. Okay, fine, fine, fine. Okay, wonderful. Yeah, okay. Now the point we are making is, yeah, somebody was asking me about NPU. We'll talk about NPU. Let's understand the GPU first, and then we'll go there. Okay, we are to cover a lot of thing. We'll talk about tensor cores. We'll talk about GPUs. We'll talk a lot. We have years to talk. You'll get all of that. Okay. Okay. So the point I was making is that GPUs are a clear reason why matrix multiplication happens fast, and that is the reason why today we see an explosion of AI. I mean, it's right to think about this, right? What is it that why did we have to wait so long? Basically because we did not have compute power. Okay, and since we are on that topic, what is the next challenge? What is the next challenge after GPUs? The biggest problem of GPUs is that GPUs do multiplications very fast, but they consume a lot of power. Okay, they consume a huge amount of power. So now the battle is shifting from chips to renewable energy. If you see NVIDIA today, some of the most interesting investments which NVIDIA has made in the last few years. The reason NVIDIA is the driving force of the driving force of NVIDIA is now towards renewable energy. Reason is they have understood that if their GPUs have to work, if their data centers have to compute, the data centers will not be compute unless there is huge amount of power available. So the next war is for power and various kinds of chips which will not heat up. You must have heard the arguments for or the search for rare earth. Rare earth, the problem is the reason for getting rare earth is using rare earth you can produce kind of materials which can resist huge amount of heat, temperature, all of this. And that's why the whole world now is chasing rare earths, is chasing renewable energy so that their AI power can be unleashed. Because GPUs are all ready, but they're all getting heated up because the demand for computation, the whole world is crunching at such a huge speed, at such a immense rate that unless huge amount of energy is available, it won't work. Unless we redesign materials, the materials will get heated up. The existing materials will get heated up. And how do I get new materials? Basically, I have the rare earth, which are some elements of the atomic table, which have some properties which don't burn or don't get heated up. Those are some properties from the atomic table elements, and those are called the rare earth elements. Unfortunately, India is again way behind in the rare earth story. So there is a huge demand, of course, for creating rare earth substitution. In fact, just like drug discovery, we are now starting another project in the next semester for material science, especially for creating rare earth substitutes. So we are going creating a lab, just like we created the drug discovery lab or the drug discovery initiative. We are creating an initiative for creating new materials. Creating means discovering new materials with robotics built in. So that's again a frontier that we want to chase, that KMID as a group would want to chase, and we are trying to see there, because India can't have rare earths. India doesn't have rare earths, but India can create what are called rare earth substitutes, and that is all connected to this GPU power, need for power, need for materials loop. You need to understand this whole economics, the technology, and the economics behind this whole loop. And the quicker you understand, the better, because it's very interesting and probably going to be your future. Okay, but going back, I'm going back to the original point, where I said in a regular CPU story, I will do this, then I'll do this, then I'll do this. On a GPU, I have huge amount of processing power. I have huge number of ALUs available, arithmetic and logic units available. I have a grid of ALUs available. What I'll do is, the smart thing to do is what? Basically, while this multiplication with this is happening, while these two guys are busy, R1, C1 is busy doing this calculation. Remember, this answer comes by multiplying all the elements over here by all the elements in this column. While this is going on, I can also do R1, C2. I can also do R1, C3. I can also do R1, C4, and I can do R2, C1, and so on. So all of these can be done in parallel, because a GPU offers a bunch of ALUs, a huge number of ALUs available. Like, how many ALUs will you need here? You'll need 100 into 4 ALUs, right? Each ALU will have to do 5 operations. Multiply this with this. But how many ALUs? I'll need 400 ALUs, because why? Because this answer has 400. This answer matrix of this operation has 400 cells. So because it has 400 cells, I need 400 ALUs available, or I need a grid of 100 into 4. This is the size of the grid which I need available, right? So we talked about this in the last session. We talked about the need for this grid and the availability of this grid in the last session, right? And now this is all a recap. Now I'm doing huge amount of recaps and spending incrementally forward, because I want you to get the picture in the holistic sense. And once you start getting the picture and you stabilize, then we will be emboldened to go faster. But I'm not in a hurry to go fast. I am going very, very slow. And 100 into 4 is the total number of cells I require. That is the number of computations I would have to do, right? Now, taking it forward, now going to the next step, we talked about this. So in order to achieve this, what we would have to do, okay, now let's get to the logic or the programming for this. So I need 100 into 4 matrix as my result, which I normally call C, and my input matrices I call A and B. So A is getting multiplied by B, and answer is C. That was the thing. and I said each of these calculations in my result are going to happen independently. That is one row multiplied, one row of this getting multiplied with one column of this is going to happen independently to get this. While this is going on, this is going on. So each row, each of these computations is called a kernel. Okay. So in order to do this calculation, how many kernels would I have to launch? I would have to launch 400 kernels. Because I have to fill up 400 cells, I will have to launch 400 kernels, right? So these are the kernels I have to launch. And each kernel is essentially a Python function which receives A, B, and as a matrix, maybe getting C, which it has to produce as a result. And it also gets two more parameters as to which row and which column it has to do its operation. On which row it has to do its operation and which column it has to do its operation. Somehow it has to get this. Either it gets it directly or it uses that CUDA grid one and gets these two parameters. It also obviously needs two parameters, which is the maximum number of rows in A and the columns in B. So that is the result of C. C is these many rows and these many columns. So it gets the dimensions of the result also as parameters. And what it has to figure out in the function. So I am correcting myself. The kernel is a function. The function takes 5 parameters. What are the 5 parameters? The matrix A, which needs to be multiplied with matrix B, multiplied with matrix C. Result is in matrix C, and it needs the number of rows. That is in C, finally, how many rows are going to be there and how many columns are going to be there. These are the dimensions of C. It needs that too. Okay. Now, what does it do as step 1? It has to get its row and column which it has to operate on. See, each kernel, I told you, has to operate on one row and one column. One row and one column. Row of A and column of B. So it has to first obtain that. So it obtains it from CUDA, CUDA.grid2. Today we'll elaborate on this. CUDA.grid2, which gives every kernel 2 dimensions, the row and the column, on which it has to work. This kernel has to work on row and column. Today we are going to expand this a bit, okay? And we'll also talk about in a moment blocks and threads. We'll talk about this. But before that, I need to know the row and column. What does this R and C mean? This row of A has to be multiplied with this column of B to get an answer. So with this kernel, I'll compute just this cell, right? This cell, because it's given one row and one column. It is given one row of A, or it is given the row number on which it has to operate in A and the column number it has to operate in B. So it has to take this row number, this column number, and produce the answer. So how many multiplications it has to do? In our case, it has to do basically 5 multiplications, because A is 100 into 5 and B is 5 into 4, right? Because we took 4 neurons. So 5 into 4. So this is 5. So basically now it has to write a loop of only 5 values. Loop of only 5. Loop for K. Okay. 0 to K or whatever. It has to do that. And it has to sum up each. It has to take each now. A, R, K into B, K, C. Each element, remember, of see this row, this column. So it has to go through each element of this row. So that is what the K will do. So K will run here and K will run here. So it will produce this K into this K. That is K values. Row K into BK goes how many times? K times. So this is all it has to do, right? This is where we discussed last time that each cell has to do, in our case, only 5 multiplications. Okay, it has to multiply 5 times and then produce C R CRC, row column of the answer. This C small, right? So it has to produce this, which is a sum of all this. After it sums all this, it has to add to this RC. So that is the kernel which we have to write. And today, now I'm going to demonstrate all of this happening using our tantric. I'll talk a little bit about tantric before, and then I'll explain how this all works. So we are going very slow, and I'm hoping you will understand. So this is where we had stopped in the last class, where I had shown you some Python code of doing this. But before that, another important idea of this we had explained last session. So if you are having a little doubt, you can go back and check. Okay. Now, a little more background of how the grid looks like. Remember, I told you that in a GPU, okay, there is cells. There are a huge number of GPUs arranged in a matrix form. Huge number of GPUs are available. Okay, that picture is there in the last presentation, so I'm not going to repeat the picture, but you can just imagine that there are huge number of GPUs, arrays of GPUs available, right? These are all arrays. Okay, now each GPU, each of this is a GPU, is going to run one kernel, right? Now I told you that GPUs are not organized just like that. These GPUs, this total thing is called a grid, which is of a certain size. That depends on the kind of hardware we have. We may have thousands of cores or more than thousands of cores. We have 48,000 cores in our A100 and that kind of a thing. So we have thousands of cores available, so we have a grid of that dimension, complete dimension. Now, in order to do a matrix, we may not need such a big grid, right? We may need, okay, but before I go there, a little bit more. Okay, this grid is now decomposed into pieces. The way it is pieces is, so I showed you. Okay, let me draw a cleaner picture and show you. So I'm going to take, I took a grid last time of 4 by 4. These are all GPUs, processing units, each of which can execute a kernel. Okay, I'm taking a 4 by 4 grid. Okay, it can be bigger. This can be total number, maybe 1,000. And grids are normally organized as blocks. Okay, so this may be one block. Okay, each block has 4 GPUs, so can run at any given time 4 threads. So my block is a 2 into 2 block. It can be rectangular, it can be horizontal also. It can be just one way also. So this is my block. This is called a block. Okay, please don't think this is a matrix. It is used for a matrix, but this is called a grid. This is called a grid. Grid means these are the compute engines available in a GPU. These many compute engines are available. In the given picture, how many GPUs I am showing? 16. So how many kernels can I run simultaneously? 16 kernels. Okay. In real life, these are in thousands, okay, or tens of thousands to be more realistic. The kernels, all the GPUs are organized divided into blocks. So this is another block. So the way these blocks are numbered are also, this is 0, 1, this is 0, this is 0, 0, this is 0, 1. This is how the blocks are numbered. This is also another block. Okay, this is 1, 0, and this is yet another block, and this is 1, 1. So these are the 4 blocks that I have. Okay, and each block now does a computation. Okay, each block does a computation. Each block has 4 threads. So each block can do 4 computations. Okay, each of these blocks. And how many blocks are there? 4 blocks are there. How are they numbered? 0 1 0 0 0 1 1 0 1 1. This is how the blocks are numbered. So this is how your grid exists. So the hierarchy is grid. Grid is broken down into blocks, and blocks are broken down into threads. Okay, this is how the hierarchy looks. This is the computational hierarchy. Okay, of a GPU, so that I can do one row and one column computation together. Okay, now we talked about this also last class to a large extent. Okay, now what we are going to do is I'm going to take you back to the kernel which I introduced last time. But now I'm going to show you not just one kernel, I'm going to show you quite a lot of logic which surrounds that kernel. And okay, now let's do one thing. Okay, I will give you that on the screen. So maybe we should open up the Jupyter notebook at this stage and
First, we will start with the demo thing.
you want to do a demo?
Yeah.
Okay.
That should be better.
Okay. Okay. So, okay. Now I am going to do a bit of a poll just to check, because see, I have spent the last 40 minutes actually just trying to get you back on the same thing, understanding that some of you have just attended maybe first time or second time, I don't know. So I'm just going to take a small poll. Are you with me so far? Okay, whatever I have described to you, you should know. Okay. Yeah. Achha, now he has given you 4 choices. Able to follow, pace is okay. Yes, I am able to follow, reduce the pace. Not able to follow, it's too fast for me. Not able to understand the concept, please repeat. Okay. I don't know whether I'll be able to do the 4th one. Okay. Anyway, let's wait for you guys to be on the same page because we want you to get it. And please, those of you who have not attended the sessions, unless you have done the requisite homework of going through the KMIT Vista, checking it out, please, that will be unfair to the whole other people to say that, just repeat. It's not fair to other people. We need to be civilized enough to understand that if we have missed sessions, go to KMIT Vista, read up about those sessions, and then come and attend the session next time properly. Okay, 71% people have voted, and looks like out of those people who have voted,
71%.
about 71% have followed. Okay, I think we will wait till anything. See, we typically wait for about an 80% vote, and we take a call based on that. At 80% vote, we have 70% who have followed. We have close to 19% who are able to follow, but they want a slight reduction of pace. And then there are those 5 and 6%. I can't help them much. Okay. Yeah. Because I'm sure the 11% who answered on the 3rd and 4th will appreciate that we can't delay everyone for the sake of few. Okay. For us, few means about 10-11% is few. Okay. So I'll try and reduce the pace a little bit, and let's see how you proceed. Because also the idea is so that you get it right. Okay. Now we are going to talk about some code. But before I talk about the code, I think it's time for me to introduce to you our platform on which you will do most of this work in the next few years on this platform. Is going to be the platform called Tantric. Okay. Now I'm going to give you a rough introduction to Tantric. Let me just tell you how Tantric is, and that is our infrastructure. Yeah. Huh? Is it okay?
You can continue.
Okay. So I'm going to give you an introduction to Tantric because today you are going to start your work with Tantric, and Tantric hopefully will be your companion over the next 2 years. It's an in-house platform, so it will continue to evolve as you are evolving, and it will become our AIML. So Tantric is to AIML what Tessellator was uh, regular coding. See, we have three main tools for programming. We have Tessellator for basic coding. We have Tufan, which is an elder brother of a Tessellator, and which is basically used for web application testing, because we can't test web applications using the core Tessellator. And we have Tantric, which enables you to write AI programs and be able to talk about AI programs and do AI programs. This is our de facto platform for AI programming, and it's a very stable, very nice guy. How is Tantric built? Tantric is built in-house, built by us. So at the core, at the backbone, okay. Okay, let me give you the architecture of Tantric, those of you who understand. So there is one, everybody connects to one portal. So this is the main Tantric. Sorry, this is the main Tantric portal, which provides you the login information. And depending upon your login, what it does is it takes you to a pool, one of the pool of GPU clusters. Yeah, it will take you through a pool of GPU clusters. See, these are all GPUs. GPUs means each one of them has is a 4 GPU machine. Each one of them has thousands of cores. When I say GPU, it's a GPU machine. It's not GPU. So it's basically each one of them has about 12,000 cores. Uh, uh, Roughly. Okay, I think there are more, but I think let's take them as 12,000 cores. This is our core architecture. And how many of them are there? There are 15 of those, 14 to 15 of those. Okay, they are all put in, managed by our Teleparadigm company, who is responsible for giving us the portal, ensuring all this stuff works, does the grading, all of that. So this is the backbone. So at any given time, when you connect, you will find a Jupyter notebook launching in your browser, and you will work on AIML not using Tessellator type screens, but using Jupyter notebook. That is the de facto architecture for working with AIML. So this is Jupyter notebook. Each one of you will get an instance of Jupyter notebook. You don't have to install anything. As soon as you connect, you will have to, a Jupyter notebook will come up on your browser, and you will start working with that notebook. So, and obviously these notebooks are stored back. And whenever you ask for any computation, when you press the forward arrow for the run arrow in the Jupyter notebook, basically you will your program will be executed by one of these GPUs. That means your work will go to one of these GPUs, and on that GPU there will be 12,000 cores. So those will be utilized by all the people who are landing up here. So if you see, currently there are about 542 people, 542 people who are logged in. So their load, in a way, not exactly, but their load in a way will be distributed across these machines. So if you take 15 machines and 542, about 30 to 40 people will land up on one GPU. That means you'll be sharing these 12,000 CPUs, sorry, 12,000 cores among these 30 to 40 people. It still doesn't matter because there will be some amount of sequencing here, but doesn't matter because there, if all of you don't have enough cores, then you'll have to wait. But that's marginal. So this is what is our architecture. This is the tantric main architecture. Now tantric also has its another avatar. This is what we will give you. I mean, this is being created, so it will be there. There is one more avatar of tantric which doesn't go to these GPUs. It basically, besides this, it also has a pool of massive GPUs, which are those A100 and H200 GPUs. We have one H100, one A100, and this is not there yet, but we are going to have two H200s. They are big power machines. They will normally not be used for tantric like exercises, not the ones which you are doing. But when we set up, massive hackathons of AI/ML programming, of model development, especially when you are creating a pharmaceutical model, or you're developing a model for material science, or you're building a model for breast cancer detection with a lot of images, uh, at that time, your work will not happen here. It will happen on our super cluster. This is our regular cluster, and this is our super cluster. Normally you will not, as you are doing now, you won't get access to this super cluster. This will not bifurcate, sorry, this will not divert you to this. It will divert you to this cluster. It will not take you to this cluster unless the logins are different, and this cluster is specifically architected and enabled. This is our super highway, and this is our express highway. So that is how it is. So by default, you will work on this. This access is usually restricted only to certain students, and that too people who are concentrating on creating these high-end models or running hackathons for building these models. Those guys will work on this architecture. They will also connect to Tantric and all that. The other Jupyter notebooks, all that will remain the same, basically, but this backbone will get altered. So this is how we actually work. This is the KMIT's backbone, and currently it is all hosted in KMIT, but soon this is going to be hosted into the Teleparadigm Towers building near Uppal. So one whole block, one part of a floor will be dedicated for hosting. This is our core AI data center, and this is right now we are waiting for some special generator power, but soon we'll be connecting it to some solar generation or something, because it is going to, especially when these guys come up, they are going to take a lot of power, a lot of heat, and we will need a special circuitry for heating, cooling, and running these machines. These are okay. These are okay, and this is also okay, somewhat okay. Once these come, there is going to be a huge power, and this next month we'll have. Uh, okay, so this is the story. I hope you understood what is tantric. Tantric spelling is XC, no?
Yes.
K. Sorry, K. Tantric, yeah. Yeah, so this is tantric. Okay, it's a very big tantra, and that's why it's called tantric. Okay, and okay, now so you can see the working area is Jupyter Notebook. Okay, so I think I have given you a rough idea of what tantric architecture is. Originally, this was supposed to have been done on Kubernetes. Eventually, it will shift to a Kubernetes-based backbone with GPUs, but we will shift it slowly. I'm not in a hurry to do that. This is not running on Google Cloud or anything. This is our own cloud. our own data center connected through these lines and all that, so that the traffic goes here. Okay. Okay. And I must add, this is very expensive. This whole architecture is very, very expensive and has cost us a lot of money. But then, if we don't give you this infrastructure, you will be useless to the world and useless to yourself, right? Okay, so it's important that you know this. Okay, so now we are going to show you how to open a Jupyter notebook, how to log in and create.
First, I want to take a poll.
Hmm.
Those who are in the live session, how many have the access, how many don't have the access?
Access to?
Tantric.
How will they know? Login.
We have shared the list also. They know they are there in the list or not.
Acha. So how? What is the question you want to ask them?
Do we have access to Tantric? Opening a poll.
They should open Tantric and check. No, just being in the list will not. Acha, just being in the list is enough.
Enough.
The list which was where, because you may have shared.
I have shared it in the groups.
Okay. So okay, Nagireddy wants to do a poll of how many of you are finding your names in that list which we shared, because only that list has access to Tantric as of now, because that list is created keeping in mind that you are attended the any session of the last session, or you have enrolled, or I mean, just enrolling will not cut it. If you should have at least attended one session. If you have attended all the sessions, you are or two or more sessions, you are anyway there. We have included you because we believe you're sincere and you want to come and do stuff. People who have not attended sessions, some of them are still there, but those are very less. Who have attended one session and enrolled. So 2 sessions, automatically you are there, irrespective of whether you are enrolled or not. On the contrary, if you have attended one session and enrolled, you are there. Okay, so that's the condition. I am sure you can understand. So we just want to check, do you have access to Tantric or not? It's by the list. So what you have to do is, I think, know your name by now, and you can check in the list whether you are there. You just have to check your name in the spreadsheet which was posted. The PDF, sorry. The PDF which was posted, you have to check whether your name is there in that list or not there in the list. It is only one of those two that can happen. And I am sure you know your name. You have figured that out by now. Yeah, if you have attended one session and not enrolled, then you are not there. For one session attendees, we have given a thing that you should have at least enrolled. We're just waiting for the voting to reach a point. If you have attended 2 sessions or more, you are automatically there. If you have attended one session and enrolled, you are there. It can't happen. Somebody is saying you attended one session.
I'll check.
We can check. Just keep your message posted here. We'll check.
Please share your roll number to me in WhatsApp, ma.
Okay. Those of you who have this kind of problem that they have attended one session and their name is and enrolled and still their name is not there, then you have to send your name to the WhatsApp group. We'll try and see what we can do. We cannot have everyone for the simple reason that though we have huge power, we have to provision everyone. We can't do it on the fly. Kernel is something which runs, core is the hardware, kernel is the software. Okay. To answer somebody's question, kernel is the software, the Python code or the C++ CUDA code that you run. Okay, I'm going to show you the code. Okay, I think we have finished our poll. Okay, looks like about 78% of the people who are attending now have access. 20%, 22% or 20% have no access. So today you will be able to, you can see the session. We'll keep record of you being attended. We'll watch for a couple of sessions because we are going slow. We'll watch you for a couple of sessions. If you are turning up for 2 more sessions, we will enroll you. But we want people to be given priority who have taken the who have attended the sessions. So obviously we have to give priority to them because see simultaneously our platform we have not tested for more than 500 to 600 connections, but it can handle I'm sure more. And right now your exercises are small, so we may be able to accommodate more. But I would like to caution that if we don't see you in these sessions, that is you are not available in these sessions or not connected to these sessions, we will not be able to take you. So we will, if you have that kind of an issue, please uh, give the names on WhatsApp to Nagi Reddy on the WhatsApp group and we'll see what we can do. Okay, now that we have established the ground truth of this session, now we are going to go forward and show you application, and if you understand just one application and how to run it and understand its impact and meaning, I think we would have moved forward. Okay, so here we go. Okay, I'm now going to walk you through a program which is probably the first full program which runs a kernel of matrix multiplication, and we will walk through the notebook carefully step by step and hopefully you'll understand. So just watch what we are doing. Okay, so now we are ready to go to Tantric. Now we'll have to start right in the beginning. Log out, yeah. So here is how we start. Okay, we go to that login, the same login they'll use.
Yes.
So the login we are using is tantric.teleuniv.in at 8881. So that is the URL, tantric.teleuniv.in. I think that has been already sent to you, and that is the login. And yeah.
If you have missed that message, please go to the ai.teleuniv.in website and join through the link, the URL link that we have started.
No, they can see the link now also here. No?
Yes.
Okay, so this is the link, please. Tantric.teleuniv, Telangana University, TELE though. Tantric.telanganauniversity.in. This is ours. There's nothing to do with the state government. It's all KMIT. .in:881. Okay. Yeah. Now we will log in. We will log in with our ID. You log in with your ID. So the username and password are the same. Okay, you will see something like this. Okay, you can close off whatever is. You should see this. Wait, you should see this kind of a screen. Okay, where you'll have release assignments, downloaded assignments, submitted assignments. Don't worry anything about that right now. And on the left, you will see Explore AI as one folder, one subfolder. Okay. Now, what you need to do is, Acha, just check whether that guy is able to see that also.
This one, no, sir. He doesn't have access.
Okay, we should give him so that we can check. Okay.
It is not accessible in mobile.
It can't be accessed on mobile. Okay. Acha, I don't know why. Well, anyway, it's a good idea that it cannot be accessed on mobile. Okay, now we have Explore AI. We will click on Explore AI and we will reach the assignment. Okay, under Explore AI, there is demo. Okay, wait.
No, sir. Nothing else. As of now, there is nothing shared with them. Assignment list, nothing is there. Yeah. I hope everyone is able to see this screen now.
Hmm.
Now I'm publishing.
Okay, now we are releasing an assignment. So once you refresh again, you will see as of now, there is no released assignment. You are able to see one demo that, but that's all empty, I guess. Now we have released an assignment. So if you refresh your screen again, you will get it. Okay, under release assignments, Baba, if you do so fast, they will not get anything.
NB grader.
Assignment list.
So
now go to NB grader, which you see at the top, and just say assignment list. You will see a list of assignments. Wait, one of the assignment that you will see is demo.
The course name is
and the course name is AI. The one on the right is AI is the course name. You can see that also. So released assignments, demo, and course name is AI. And now you'll have to do a fetch.
Yeah.
Okay, now we have released the assignment. So you refresh your page, you should be able to see the release assignments. And now, no, once they fetch, we'll take a poll.
No, are they able to see it? Please confirm, are you able to see this?
Couldn't see the Explore AI.
You can't see the Explore AI file yet? First,
no, we'll have to
confirm, are you able to see the
Asha.
demo in the assignments?
Released assignments, right?
Yeah.
Acha, we will take a poll because I think it's important to take a poll. You should be able to see really after you have refreshed the page, you should be able to see demo AI under released assignments. ఇక్కడ ఒక ల్యాప్టాప్ వస్తుందా then you have to click NB grader and say assignment list. Then only you will see the released assignments. You see the notebook grader, NB grader at the top menu. Yeah, we are launching a poll just so that we know how many of you are able to see. Okay, the answer to this question is, are you able to see our assignment after you clicked NB grader? Please click NB grader. Don't click fetch as yet.
This poll is only for those who have the access to Tantric.
If you don't have access, obviously you can't see. Yeah, click on NB grader please and say assignment list. NB grader assignment list, you have to click to see the assignments. Don't click fetch as yet. I think voting has come to an end. It's not moved. You just wait for it.
79%. Yeah.
Because some of them don't have access also.
And
Okay, fine. Rest of you watch what we are doing. I'm sure, hopefully, in subsequent sessions, we may be able to enroll you and proceed. Okay. Now, no, you have to proceed now. Oh. Now we are fetching the assignment. So, wait. When we have fetched the assignment should come under downloaded. Released assignments means we have released them at our end. Fetch means they are now accessible to you. That means they have come onto your laptop or to your server. Not necessarily to your laptop, but to your server. That is, one of the servers is now going to pay you attention, and your assignment is available on one of the servers, your copy of the assignment. Because each one of you has a separate copy of the assignment. So your copy of the assignment or the work is available to you now at downloaded. And now, once it is downloaded, don't click submit. Okay. You have to now open it. No. So submit is after you are finished. Okay. So right now you just click on demo. Don't say submit. Under demo one, demo, you will see demo one, and just click on it. Okay. I hope you have done that. Okay. Again, downloaded fetch will take you to downloaded assignments. Under downloaded assignments, there is demo, and if you open demo, you will see demo 1. Click on demo 1 and don't click on validate or anything, just click on demo 1. Now your Python notebook, IPNYB, is Python notebook, interactive Python notebook, demo Python notebook, that is now open. Okay. Now I am going to illustrate this stuff. Okay. ये क्या लेके आए?
Everyone,
Ah.
here you'll be seeing whenever you have to write something, you'll be seeing something like in a comment your code here as the message. Okay, that means you have to type something there. Means you have to write your code there.
Yeah. Now don't type anything. Okay.
And now you are seeing a error message like rise not implemented error. You have to remove this line. Make sure that you have removed this line below that comment. Okay. Under your code here, previously, you will be seeing this error, rise not implemented error. You have to remove this or comment this. For your sake, I am commenting that error.
You have to raise that, comment that also.
Comment that error. And this is a common error message in the code. So here, everyone, please type a if conditional statement. If n less than 1, if n should be 1 or more, if it is less than 1, you should write this error. So this is a comment, sorry, this is a conditional check. If conditional check, if n less than 1, it should write this error. Otherwise, it will return this square of numbers from 1 to n value as a list. So these are the checks that we are making here.
Yeah, okay.
Passed one.
Just to add to what Nagireddy is saying, see, we have given you a template which you have to edit. Now, this is not the program that we are going to use today, but this is just to show you how you should execute code on Tantric. Okay, today we are not going to ask you to execute, but it's better that you try this. Now, if why is still giving an error?
No, sir. I didn't run it.
Okay. So you edit that code today if you want. If n is less than, this is a demo program. If n is less than 1, raise value error, n must be greater than or equal to 1, and return I, whatever.
Squaring of numbers from 1 to n.
Yeah. So this logic is for getting all the values or squares of all the ones from 1 to n, because range is n plus 1. It gets the square for all the numbers. And I don't know whether the assertions are correct here.
Yeah.
Okay, if you say 1, it gives you a set of squares. Okay. It builds you a list of values which are the squares of numbers from 1 to 10 or 1 to 2 or whatever, okay, including both. So if you want to check it, you just press the arrow button at the top.
Run this cell.
Yeah, just run that cell. And if the assertions are true, you will not get any error.
That's it.
Yeah, that's it. If you are not getting any error, you have a problem. Or you don't have a problem. If I goof up, okay, if I write wrong code, let's say in place of I into exponent of 2, no, make a change there. You say I have an exponent of 3, which is a wrong value because you are asked squares, you are not asked cubes. Now, if you run it, your assertions will fail. Yeah. See, the assertions have failed. These were the assertions. Okay. Assertions means for one answer should be this, and if it doesn't come, it will fail the things. Okay. Okay. Now that you are seeing this and being able to run some of it, we'll edit the code back. And now if you run, you see there are no failures. So it means it's running. Okay. Now, since we are on that point, okay, I will give you an understanding of what and how these notebook exercises work. Since we are at right in the beginning, maybe this is a good part to invest some time and show you how do we go about doing this. So normally, I'll give you a little background and then I'll explain this because many of you are new here. You should get an understanding of how it all happens. So I'm going to give you a little conceptual thing about a Jupyter notebook and how it runs and all of that. So let me do that because I think you are seeing a Jupyter notebook for the first time, some of you. Okay, So let me give you a background. Okay, Jupyter Notebook is basically a notebook in the sense it's an editor for writing code in Python normally for AI programs. Okay, so normally the execution or the Jupyter Notebook is broken into cells. Oh my God, this is where my handwriting, drawing skills go bad. These are called cells. This is called cell 1. This is called cell 2. And there can be hundreds of cells in a notebook. These are cells in a notebook. So normally all of us Python programmers write code in some cell or other. Okay, we write cell. We write it in one cell by cell. Okay. Now normally this is all chunks of Python code. Chunks of Python code. Okay, it can be used for Java also, but traditionally we don't use it for Java. It's mainly meant for AI kind of applications. The traditional tool is this Jupyter Notebook. Okay, and that's why we are familiarizing you with that. Now each of these cell can have code. Okay, and it will have code. Now there will be some cells which right now this cell is visible to you, but normally there will be cells which are called grader cells. Okay, these cells will be invisible to you, to the student. These are called grader cells. So some cells you are supposed to write code. After those cells, there will be these grader cells silently sitting there. They'll be invisible to you, invisible to the student. What will there be is, there will be code here. Who writes the code? Nagireddy or the people running this program, which is Anuradha madam, then other people who are executing this program, who are helping me run this program, they will be writing this code. This code in these cells will be written by our team. And what is the job of this code? This code doesn't do anything new. It just checks whether this code is running correctly or not. Has been created correctly or not. Since they are part of the same program, any variables you have created, the value of the variables here will be checked. So variables are here. The value of the variables I will check here. Or if you have created a function here like square, I will call the function with a particular parameter and check its return value whether it's expected that or not. So that is how these grader cells work. They are silent hidden cells which are intermingled with your program. They are interspersed with your programs, with the notebook that you do. So some of the cells you code, some of the cells we code, and that is to check whether what you have coded is correct or not. Okay, so these are called grader cells. So they will be the criteria using which we will evaluate and give you marks for the code we ask you to write here. Your code will be all written here, wherever, and below that we will have our graders sitting silent. Now they will be generally invisible because the student should know what the way we are going to grade, the way we are going to call your function and all of that. But in the current exercise, they are basically a set of assertion statements, or there may be other logic also. Assertion means checking whether something is correct, expected value is what we get or not. So that is what is called an assertion. So is that there or not? That is what it will check. So basically, in order to check that, we need these grader cells. Okay, so this is what is the architecture of our Jupyter notebook. The real Jupyter notebooks that you get in the market are not having these cells. Okay, they are just Jupyter notebooks through which you evaluate and run code. So there is a run symbol at the top which is used to run, and it will run cell by cell, or if you click on a particular cell and run, it will run that. So this grader cells will not be there normally in any Jupyter notebook that you download and work. They'll be there only in the Tantric Jupyter notebooks for evaluation. Okay. Otherwise, we can just serve you Jupyter notebooks and be done with it. No use. But this thing is there so that whatever you have written, automatically gets evaluated and checked and all of that. Okay, so that's the spirit behind writing these grader cells, and they are kept hidden. Now, with that background, let's look at what is the demo that I have. That is just a demo. It's nothing to do with the program that we are going to do, but just to get you familiar with Tantric. So, no, just show demo once. Yeah. So this is the demo. You can see now there are two cells. There are earlier cells also which have some includes. No, I think the first cell itself is called 6. Huh?
Yes.
Okay. They can be numbered any way you want. They can run from 1 to n.
This number will be generated by system.
It's a system generated number, so you don't care about it. Okay. So here the logic of the first cell, that is cell number 6. Now cell number 7 that you are seeing here will not be visible normally. Okay, since it's a demo, we have made this cell visible to you. You will not see cell number 7 normally. Okay,
They can't edit.
no, they can see, is it? No, they shouldn't be able to see also.
That way will.
Right now we are able to show you the cell, but you can't edit it. But that's okay. Actually, in advanced exercises, you will not even see that. Okay, you will not be able to see this cell also. Okay, right now you are able to see, but I think you are not able to edit it. We will edit it. So this is what is the logic we expect. This is the answer which we are checking against. Okay, so this is what it is. So you can run it and see.
No.
No, let them run once and show.
Yeah.
So we are just going to run it one more time with this explanation. See, there is no error now. You run. See, there is no error at the bottom, right? If I make some bug, I will have an error, so it won't run. Okay. Now what do I do? Once I have finished this exercise, what do I do? Okay. The thing is, now having written the code, here you didn't have to write even one line of code, but in real life, that cell number 6, what we just saw, would be coded by you. Here we just did some basic editing or something. We just wrote one line or whatever. And that's all we did. Now we can check whether you have written correctly or not, and you can do validate or a submit. Normally we don't do validate.
Submit.
Okay, normally validate is not required. You should just after you're done and you're happy with the way you're running, you just say submit. So when you submit, the code gets submitted to us for our checking, because though that is at this point, we will run the grader cells again. When you submit, run the grader cells again. Whatever you have done now gets stored not on the screen alone, but gets stored in our database. The evaluation happens in our database, and your result is stored in our database, and we will show you the result also. You can yourself say fetch feedback, which is fetch the evaluation and get it back. Can we do fetch feedback?
No.
No, but then there should be some flag which says that fetch feedback won't work, no? Okay, if we have not evaluated, your fetch feedback will not give you anything back. Okay, now we are got the assignment. Now we will show you our screen. No, we should have shown them our screen. Where we
okay. Once they become fetch feedback, if they are able to see view feedback.
Once you are able to see that blue thing, view feedback, if you are just able to say fetch feedback, no use. If you say view feedback, then you go on the left, there will be an HTML file now given to you. So you click on the HTML, now you will get your score. There were two assertions which were evaluated. So you got full 100 out of 100. So two tests were run, maybe two assertions.
Two cells. We marked as two cells.
Okay. This was marked as two evaluations.
Yeah.
Maybe you ran it twice. Okay. And you got full score. Okay, so that is what you will get. Okay, that is in the view feedback. You will get your score. Okay. Now between fetch feedback, if you don't see view feedback, that means we have not executed, we have not yet evaluated it, because that is, we have not asked the GPU to look at your code and make it execute. Okay, so I'll walk through this again very fast. So we give you an exercise. Now you download it. Sorry, first you go to assignment list. You will see the exercise. Again, you will see under released assignments. That is when we release an assignment. And then you will say fetch. And once you fetch, you will see it under downloaded assignments. Then in downloaded assignments, you click on downloaded assignment. You will see its sub notebook. Can you click on demo? You'll see that demo. You click on demo, you'll open up the notebook. Once you are on the notebook, then you can do some editing of the cells, write some code, all of that. And once you are done with that, you will try it out on your own by saying run. Just like Tessellator, you have a run. If you're happy, it's not showing any errors, then you're fine. All assertions are working. And then what you do is you go back to assignments and say submit. Now you say submit. Now you see, wait. Now you have submitted your code. Now I'll show you what we do at our end of the story. Okay, we will show you what we do. I'll show you our portal so that you also get an understanding how these systems work. Okay, now this is our side of the story, what we are seeing. So we are seeing our control panel, test center, select AI course, demo, students. So we will see all of this here. Okay, so we'll see here about 177 per students have evaluated it correctly. Okay, 193 have evaluated it correctly. So this is our screen. This is a previous evaluation. Okay, so unless we say evaluate, you will not get feedback. See, you will submit, it will show up here, but unless we hit evaluate, it will not do evaluation. Okay, that is, you will not get feedback. Only when we do evaluation here, you'll get your feedback. Okay, now, okay, one more thing I'll show you. Those of you understanding, okay, because you have to understand how systems work also. This is an in-house system. You're seeing, are you all able to see the server column? Yeah, this is the server, the GPU cluster. I told you about the GPU cluster. We have 15 odd machines. So these are the numbers of the server to which you went. So your evaluation, for example, Neela Vishal, I'm able to see the name Neela Vishal, maybe first year student because 25 roll number. Her evaluation went to a server 206. Neela is, oh sorry, I'm sorry, Vishal. Okay, sorry. Oh, it's a boy. Okay, his evaluation went to 206. Sri Harshita is a girl. Her evaluation was done on 211, like that. Okay, so now you can see that you're seeing the evaluations and all of that, and some of them you are not able to evaluate. Let's see why. Okay, some of you are, these 54 people are having some issues. Okay, let's see these zeros. Okay, we'll see their notebook. No, open their notebook. This is, he has not changed his code. You see this boy, is a boy or a girl? Gajjala Kaushik. Yeah, Gajjala Kaushik. See, why he is getting 0 is because he has not bothered to change the code. He should comment out all of that, and even if he comments out, it will work. Okay.
Comment out and then add this line.
Or he comments out both, it will still work, no?
Yeah.
In this case, it will work.
Yes.
Okay. So he has not done it, so that's why it's not working. You can see the same problem with that other person who is not submitting. Somebody else who is getting a 0. This person, yeah, he also has not commented his code. these two lines. That's why he's getting a error. He's not getting grade. If he does that and submits, he'll get the grade. Okay. I think the same problem will persist with others. This is how we will look at your code in case you are having issues. Okay. Now let's see whether some people have submitted and got better feedback. It has improved a bit. So out of 25, we are having a certain number. Still, there are some people who are not doing it. Now, what is the error with this person? There has to be a space between F and N. If and the condition has to have a space. If that person puts that space, Aditya, is it?
Yeah.
Kale Palli Aditya.
It is, I think, Srihari.
Or somebody. Okay, it has improved a bit, but not yet completely. This is the change. Now we are waiting for most of you to finish so that at least you get a grip of what's going on. Yeah, Mohammad Akif. Just show Mohammad Akif. Mohammad Akif is this is we have not commented that code, so that's why we are getting an error.
Comment these two lines.
You have to either comment these two lines or write if n less than 1 and all that. Okay, please do it carefully. I'm still waiting because I don't mind investing this session in just getting you completely grooved into this Jupyter notebook, because this is a huge investment for us in terms of your AI ML journey, because this is going to be the Kurukshetra on which you will work in your AI ML, and you have to become valuable. You have to work on this platform.
Yeah, indentation issue.
Yeah, this is an indentation issue in Python. You can't just write colon. The raise has to be tabbed in, or if has to be tabbed out. You have to tab out, because see, Python doesn't have an open bracket and a closed bracket. So basically it needs tabbing as a mechanism to separate. I'm still waiting for some more people to finish. I don't mind investing this session just to get this right. Yeah, we can, and we can ask them to look through the code and before they come for the next.
2 minutes. And if you have doubt, please refer to the PDF which is shared for you to see that manual. There is a
when you log into Tantric at that time itself, we have a manual also which describes all of this.
You have shared it in the group also. Please refer to that manual.
See, there is another thing which I must say this. See, while this product was being developed, we were working with your seniors and they were helping us develop this product. They were testing it and all. So I must put on record, like I do, that this product has evolved to this level after a lot of a lot of stumbles, I would say, a lot of obstacles and stumbles. And at this point, I will want to put on record the the contribution of your seniors in terms of their patience, in terms of their ability to give feedback to help improve this tool. I remember first day when I launched Tantric in that hall in our Sardar Patel auditorium in KMIT. It was a disaster. It hardly worked because though the GPUs were there, though the A100 was there, the way we were separating traffic, the way we were managing the assignment was so clumsy and clunky that had I been in the class as a student, I would have vomited. but I must applaud and accept with grace the patience which your seniors showed while the product was getting ready and prepared. So I want to thank them on this platform also, that now we are sitting at a very mature version of this platform thanks to the patience and frustration of your seniors. Yeah, we are at 294, but I think we can do a bit better. I'm just waiting for almost everybody to get a hang of this. Okay, there's still Nagi Pogu Akhil.
This has to be
This has to come out. See, the indentation is only for the raise, not for the return. The return should be on the same line as if and the same level as if.
And please don't use space, no. Please use the tab.
Yeah, all the spacing and indentation should be done by tabbing. Get into the habit of doing tabbing, not space. Tabbing is very correct to orient. Yeah, this is also actually okay. Not evaluated. Yeah, we've reached 300. Okay, while we are waiting, I will give you another small Python exercise to do. Okay, we'll just wait for 5 minutes. I don't want to go to matrix multiplication yet because I want you to get familiar with the Python notebook and with Tantric. Then we will move forward because it's better that we go everyone with consolidation. So Nagireddy is just creating one small exercise for you, and just wait for a couple of minutes, maybe 3 4 minutes. It will take us to create an exercise. We'll give it to you so that we go through this exercise, this loop again, and you're confident of doing it. We'll give you a clean cell to run this time without any comment or anything, and we'll just write our assertions. We'll just write our grader, that kind of thing. Just give us 4 minutes. Yeah, so we have enabled one more exercise, so we will release it or release already.
No, release. Go to release.
Okay, we'll show you the screen and we'll release it so that you can follow the process. Okay, so we are refreshing our screen. This is our screen, so you just observe what is happening. Yeah, we have demo 2. Yeah, okay. Now just observe what we are doing from our side. This is for only information. See, we have created a new assignment called demo 2, which we have added to our database. Now we are going to publish it. Now, once we publish it, yeah, let's publish it. Publishing it, now you know what it does. It takes it and gives it to okay, watch it. Since you have to understand this, see, assignment has been published means the Jupyter notebook has now been transmitted to all the nodes in the cluster. All the 15 nodes in the cluster have now got this assignment. One copy of the assignment has been sent to all the 15 nodes in the cluster. So that is what has happened. You should understand the way it is working. Okay, so now that that is done, okay, this is called publishing. Now we will start it. Start it means it will get released to each one of you. One copy will get released to each one of you from your respective server. So now we will see the student dashboard. Okay, now if we go and see NB grader and check, yeah, refresh the screen. Now you will see, wait. Now see, under released assignments, it has come demo 2. Now why did this come? The reason it came is basically because we published it and started it. Publishing just takes it to the servers but does not instantiate it on those servers. unless we instantiate it on those servers, you will not be able to fetch it. So now it's instantiated also. Now you can fetch it. So now you just say fetch. Now you will get downloaded. Now this is downloaded in your private directory in the server. So it has now been retrieved from the common server into your private directory on the server itself. Now there is demo 2. So it has been retrieved. So now demo 2, you can see at the top under downloaded assignment, there is demo 2 under demo 2. Okay. Now you click on demo 2, you will see the assignment demo 2. Okay. Now it's called squares, but we forgot to change its name. It's still called squares, but it is doing cubes. Okay. So you change the code accordingly to supply the cube. It should produce the cube of everything till n, same as earlier. Only thing is, instead of producing squares, it should produce a set of cubes from 1 to n. It should produce a list of cubes from 1 to n minus 1. Huh?
Yeah, and every time they have to comment this line for sure.
Yeah, and that line has to be commented or deleted. Yeah, so your code has to be put here in a proper way to produce cubes of n. Though we are calling the function squares, it's actually cubes. And where is the grading?
Grading will be hidden.
Acha, now you have seen the grading is hidden.
Means that hazards are hidden.
Okay, the hazards are hidden. Okay, so we will check. We will not show you how we are checking, but we will check. Acha, please don't change the name of the function. It is still called squares, correct?
Yes.
Okay, the name of the function is still squares, but it is supposed to produce a cube from 1 to n. So you have to write a for loop to produce a list of squares from 1 to n, just like what you did 5 minutes ago. You have to produce a list of cubes. Yeah, let's see who goes first. Oh, somebody has started also. Good. Yeah. Not square, Baba. Cubes we are saying, na. You guys don't listen. We are saying produce cubes, not squares. Acha, we have kept the function name same, but you are supposed to produce cubes. You know the difference between cube and square, no? Students. Evaluate. Wait.
Yeah. Everyone, please wait a minute.
Acha, wait a minute. I think our results are not correct. So what is it saying? Just see what the feedback is giving. Just wait. There is some error on our side. For some reason, our assertions are not engaging correctly. Yeah, just hang on, guys, for a minute. We'll just give you a corrected version.
Yes.
Yeah, okay. Guys, just pause a minute. There is something called demo 2, demo Roman 2. Do that. That is a cube assignment. This is the demo cube. Or you have given the code also.
They have to write the first lines.
You just have to comment. Okay, this is only to test again. We are hoping that you will write code, but we have given you the code. So only thing you have to write is, this is just to test whether things are working correctly. You can remove that, just put that line and that's it. It's only thing you see here is that the assertions are hidden. Let's hope it works correctly. Yeah, just submit it. Edit it and submit it. Demo 2. Demo hyphen 2, 2 in Roman. You actually don't have to do anything at all.
Just remove that.
Just remove some stuff and nowhere. Now it's working. Okay, this is just to check whether you are able to do fast or not. It's just a kind of a revision. Okay, so this went, this session we took you through a trip of Tantric and revised some of the initial stuff, but we didn't do much new. Next session, we will now start playing with Jupyter notebooks where we'll start developing different kernels. First, we'll do with MatMul, matrix multiplication kernels and how to call them and all of that. So in the next session, I'll assume all of this is done and we'll straight away jump to doing stuff. Okay. Yeah. So please finish this exercise and so that it gets recorded with us that you have come, you have finished the exercise. Because from now on, your attendance will be tracked on this platform based on what you have finished, not that you have come. So it's imperative that you finish. Okay, we'll do a quick poll. So are you comfortable with, are you able to work with Tantric? Yes. Launch. There are about 375 people. We just have a quick poll. This is for people who are, for us just to know whether you are comfortable with Tantric. No. Okay, let's see how many of you finished the exercise.
Those who don't have the access to Tantric now, we can't give it immediately. This will take some process. So please wait for the update from our side. You can put your request if you have attended a class and enrolled, but your name is not there. We will re-verify it, and if there is a yes, that means you have attended and you are enrolled. If that record is with us, we will definitely enroll you. But please wait for an update. It won't happen immediately. It will take 2 days time.
Yeah, I think by next Sunday you should be on. We'll try to accommodate maximum possible who are attending sessions. See, we want to do it in favor of people who are regular and attending so that they can take benefit of this. I don't want to just invest and waste our GPU resource on people who are not sincere or not interested in their career and life. So we will not see, there's nothing which we can do if you're not interested. So in case you are interested, just send a note, message to Nagirati on the WhatsApp group which is there, on various WhatsApp groups. I think there are 2-3 WhatsApp groups. So send in whatever belongs to your college and we will be able to help you. You'll have to share your ID, roll number and say that name and say which session you have attended and whether you have enrolled or not. Okay. And please say honestly, don't waste our time by trying to check and all that. Okay. So I think we'll keep the system. See, there was one question somebody asked about this system being available throughout. See, for these small exercises, you don't need the system. Uh, yeah, we couldn't hear you for 15-20 minutes because I was silent. Some demo was getting done, so that's why you couldn't hear me. Uh, and yeah, so hopefully now you are able to hear me. No, yes. This mic is not on. That mic is on.
Yes.
Yeah. Okay. So, yeah. So the idea is that we want to make these sessions very productive and very inclusive. We want more and more people from all our 4 colleges to participate who are interested. It is imperative that these sessions are attended and done, because if you don't get these sessions, I don't know how your AI journey will be. Though we teach that in college, this is a much better interactive platform, and you can probably get things in advance rather than waiting for that to be available in college. And it will go into more depth, and it will run in multiple years. It's actually planned as a 3-year program, and we will see how we run it. Okay.
Yeah. And some of you are saying that you have gone through the recorded videos either in GoToMeeting channel or Vista channel. We can't find that record, so we could not help you with that kind of request, please. If you have attended the session live, then that attendance is with us. We can check with that attendance only, not with the KMIT Vista channel or GoToMeeting channel where the recordings are available.
Yeah, merely seeing recordings is not attendance. Yeah. Okay, let's just see KMIT Vista whether it is there.
Yes.
So I'm just seeing KMIT Vista in front of you to see whether that playlist is there or not. YouTube KMIT Vista. Yeah, these are the sessions. Session 3 have been done. Today's is session 4. So these are the sessions. 3 is already there. By tomorrow evening, I think we'll have the 4th one also available. That is today's session, also available, and you can go through. Uh, and I think these are all clear and easily played. Let's play one and see whether it is playing correctly.
McDonald's is not failed.
It's about the burger.
You said it.
You have to watch the burgers.
Until unless we pay for it.
Hey, that's a good name. Bigger, fuller, yum yum. Come, try our.
This is not part of the class, though. Huh? This is also not part of the class. I would like to know, are you able to hear me clearly or not? I mean, am I audible? Just to check whether the chat is going on properly or not, because now we can access or we can see your chat. So my first question is, are you able to hear us? You can go forward. Or do a poll. Have you understood 9 multiplication? And the smart algorithm that I'm going to talk about, the parallel algorithm, is what is required to do this. See, this is like a highway. Think of it as a highway. Okay, rather I would say an expressway. Let's call it. The current word is expressway, or something like that. Now you have an expressway. So who is an expressway with all the values in this column and add them and produce this value? That's all it is going to do. So it needs what? One row address, this row address, this column address. That's it. And once it gets that from the sure by tomorrow evening, and I will repeat some of this next session just to. I think it's okay. It's crystal clear. I can't get better audio. Yeah. Okay. So we will put up the session 4 on tomorrow evening, and you will be having it. So please go through it in case you have missed or not understood. And I think about 79% people are saying they are comfortable working with Tantric think remaining have some issues of being able to, you know, not getting login or whatever. Well, we'll see if we can sort it out as quickly as we can. We want more and more people on this platform. Okay, so we'll call it uh, for today. We'll stop here, and we expect to see you next Sunday. Actually, these sessions don't stop; they just go on. Huh? There is no holidays to these sessions. Okay, midterms or this term or that term, we don't stop. This is once these sessions are engaged, they are engaged forever. So they don't stop at all. So that's the spirit in which these sessions are held, and they will never halt. Okay, so they'll just go on. Okay, thank you. See you next Sunday.